All right, prime factorization. This one takes a few steps to do, and it's having you write it from the factors from least to greatest. And remember that 1 is not a prime number. So we're just going to go through a few of these together. So our first number that we are finding the prime factors for is 90. Get my piece of paper and pencil. Okay. So I'm going to use the factor tree as like they showed you before. What they did before is they were writing their answers with exponents, and when you're typing your answers here, it doesn't have you do that. So we're going to do it without that. So 90 is an even number. Any number ending in 0, 2, 4, 6, or 8 is an even number. All even numbers are divisible by 2. So I'm going to start there. 90 divided by 2 is 45. When I come to a prime number, I'm going to circle it. 45 is not a prime number. Any number that ends in 5 or 0 I know is divisible by 5, so I'm going to do that. 45 divided by 5 is 9. If you want to be doing this with your calculator, you would just be plugging these numbers in. 45 divided by 5 give you 9. 9 is not a prime number. 9 is not an even number. I can't divide it by 2. It doesn't end in 0 or 5. Can't divide it by 5. But I do know that 9 is divisible by 3. And if I do 9 divided by 3, I get 3. So 3 is a prime number. 3 is a prime number. I'm going to circle those. So my prime factors for 90 are 2, 5, 3, and 3. What you'll find is if you put 2 times 5 times 3 times 3 in a calculator, you'll get 90. I'm going to plug these answers in now from least to greatest. So I have the smallest is 2, the next is 3, the next is 3, the next is 5. So I'm going to enter the number that belongs in the green box, and that would be 2, 3, 3, 5. Okay, next one. Find the prime factorization of the number 245. Oops. No, I don't want to save it. No. 245. Okay, 245 is not even. I will not divide it by 2. It does end in 5, so I'm going to divide it by 5, which is a prime number. I'm going to circle that 5. In my calculator, I'm going to use my phone, but you can use the Google calculator. 245 divided by 5 gives me 49. 49 is not even, can't divide it by 2, doesn't end in 5 or 0, can't divide it by 5. But I know from multiplication facts that I've memorized that 49 is divisible by 7. If I do 49 divided by 7, I get 7. 7 is a prime number. It can't be divided by anything but itself, 7, and 1. So my prime factors for 245 are 5, 7, and 7. 350. Okay, let's do something a little different here. I know 350 is an even number, so I could divide it by 2, but whenever I get a number that ends in 0, I think, okay, divisible by 10, that's easy. So my first branch of my factor tree, I'm going to say 350 divided by 10. And that would give me 35. Now, neither 10 nor 35 are prime numbers, so I'm going to make some more branches. Okay, 10 is an even number. Divide it by 2, which is a prime, so I circle it. 10 divided by 2 is 5. 5 is also a prime, I'm circling it. So I'm done with that branch. 35 ends in 5, so I can divide it by 5. 5 is a prime, I circle it. 35 divided by 5 is 7. Circle that as well. All right, I'm done with my factor tree, down to all prime numbers. So I've got 2, 5, 5, and 7 as my prime factors from least to greatest. 2, 5, 5, 7. Okay, right, find the prime factorization of 117. No, I don't want to say that. 117. Not an even number, can't divide it by 2. Not a ending in 0 or 5, can't divide by 5. With this one, I might just kind of take a guess so I could start typing in my calculator. I'm going to do that on the Google calculator if it works this time. Let's see if 117 is divisible by 11. Ugh, not 111, nope. Killing me here. 117 divided by 11 gives me 10.6368, blah, 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 blah. So I can't divide it by 11. I need to get a whole number, not a decimal. No decimals. 117 divided by, let's try 13, equals 9. Okay, I got a whole number. So I'm going to write down 117 divided by 13. I got 9. 13 is a prime number. I circle it. 9 is not a prime number. 9 can be divided by 3. So I've got my branches. If I want to, I'll just double check on my calculator. 9 divided by 3 gives me 3. 3 is a prime number. I circle that one. And now I am factored down to prime numbers. So there's no more branches I need to draw. So in order of least to greatest, my prime factors for 117 are 3, 3, and 13. Okay, find the prime factorization of 68. 68 is an even number. So off the top of my head, I know it's divisible by 2. If I do 68 divided by 2 in a calculator, I get 34. 34 is also an even number. Divide it by 2. 34 divided by 2 is 17. 17 is a prime number. So in order from least to greatest, I have 2, 2, and 17 for my prime factors. If you're wondering, how do you know what these prime numbers are? I have made you guys a little cheat sheet. Let me see where I put it. And it lists the prime numbers so that if you're like, I don't know if 17's prime, you can just quickly check and see. I think I put it here. Prime and composite numbers. Yep. So I've got this PDF here. You can take a peek and check that out. And all of the prime numbers, it looks like, are green. 2, 3, 5, 7, 11, 13, 17, and so on. So prime numbers only can be divided by themselves in 1. Okay, now where was I? 2, 2, and 17. 2, 2, 17. Okay, find the prime factorization of 150. Off the top of my head, it ends in 0, so I know it's divisible by 10. 150 divided by 10 equals 15. 10 is not a prime number, neither is 15. They both end in 0 or 5, which means they're divisible by 5. 10 divided by 5, which is prime, is 2, which is also prime. Done with that branch, move on to the next. 15 divided by 5 is prime, is 3, which is also prime. So in order of least to greatest, my prime numbers, my prime factors for 150 are 2, 3, 5, and 5. 2 and 3 and 5 and 5. Okay. I feel like we've covered enough problems, so I hope this video helps, and if you still have questions, please email me and we will schedule time during office hours to do some of these together.